There we go. All right, number 20. 20 was, I believe, the limit as x approaches infinity of x sine of 1 over x, if I remember from looking at it yesterday. Is that right? Yeah? All right. So this one is, if I plug in infinity, this becomes an infinity times the sine of 1 over infinity. And 1 over infinity is 0, so this is infinity times 0. But we sort of have an issue there with that, because infinity times anything should be infinity, but 0 times anything should be 0. And especially because we're talking about a limit here, we have to think about which one of these things is happening more quickly. Like one of these things is happening more quickly. We're either going to 0 more quickly, or we're going towards infinity more quickly. So there's some sort of issue here. We might be going to them at the same rate, which could cause an issue also. So we have to find a way to rewrite this so that it is no longer 0 times infinity. And the best way to do this is to do a U substitution. You guys, I know we didn't review the U substitutions on limits, but hopefully you remember them. We're just going to let U equal 1 over x. And if we let U equal 1 over x, well, we got to do a couple of things. One, we have to figure out what is x equal. So if U is 1 over x, what is x equal? So I'm going to replace that. Could be 1 over U. And as x goes towards infinity, what does U approach? U should go to 0, right? So we got the limit as U approaches 0 of sine of U times 1 over U, which would just be sine of U over U. And that's one of our limits that we just know, right? That's the limit is U approaches 0 of sine U over U. That's one we should just have memorized. That should be 1. And if we don't remember that that one's just 1, which you should remember that that one's just 1, you can always just say, oh, it's 0 over 0 and use the L'Hopital rule. Cosine of U over 1 and then cosine of 0 over 1. That makes sense, right? Yeah. Everyone good with that? All right. Other questions from the limits multiple choice that you've been working on? 28. Those of you at home, if you have questions, just type them in the chat. We'll just get to them today sometime. All right. 28. And they're talking about the greatest integer function. Y'all are familiar with the greatest integer function? I think we talked briefly about it sometime back in the first quarter. Or no? I think we did, but greatest integer function is this one. Be like, oh yeah, I've seen that before. Right? Remember that one? Yeah. No? Yeah. Greatest integer function. So it says what's the limit as x approaches a half of the greatest integer function. Well, as we approach x equals 1/2, that's right here. So from the left and from the right, it's approaching 0. So that one should be 0. The greatest integer function. The greatest integer function means the greatest integer less than or equal to x. Right, so if x is a half, the value of this function is 0. Right? Because 0 is the largest integer that is less than or equal to a half. So all the way up until I get to 1, all the way like 0.99999, the largest integer that is less than 0.99999 is 0. But as soon as I get to 1, it jumps up to 1 because 1 is the greatest integer that is less than or equal to 1. Does that make sense to everybody? How that function works? At home, you guys good with that?
Yeah.
Wonderful. They're louder today, I feel like. Do they seem louder? Yeah? So yeah, it's got the volume turned up correctly. That's good. All right, other limits questions. Now that I've thrown the book on the ground. Oh, we got a question in the chat. That's exciting. I don't know. Now I gotta find the one that has the page that has number 29. No, 29 is not -2. 29 is E. Should be non-existent. We'll do that in a second. 13 and 17. Okay. All right. 13 is talking about the graph of the inverse tangent of x. So first off, what does tangent of x look like? Tangent of x looks like this. Right? Well, the inverse tangent of that should just be a reflection of this. The inverse of this, right, should just be a reflection of it over the line y equals x. Okay? And so if I have vertical asymptote on tangent at pi/2 and -pi/2, then that means that the inverse tangent or the arc tangent should have asymptotes. Vertical, horizontal asymptotes at pi/2 and -pi/2. Inverse tangent of x is going to look like this with horizontal asymptotes. That makes sense, Angelina?
Yeah.
Wonderful. So that one's good. D. Yeah. Everyone here good with that? All right, and then 17, we're looking at 2x squared plus 4 over 2 plus 7x minus 4x squared. And we want to know which of all these things is true. Okay. So the first thing it asks about, or first thing that we would notice is it's talking about vertical asymptotes and horizontal asymptotes. The first thing we might want to do then is figure out what the vertical and horizontal asymptotes are, and then we should be able to pick from the list. Okay. So the vertical asymptote should come from factoring the denominator, right? I'll agree with that. It's vertical asymptotes from factoring the denominator. So probably factor that more easily by taking -2 out of it, and then it becomes a positive 2x squared minus x and a -1. And then we'll factor that, which, what do we want there? We'll minus here and plus there. So we see that as vertical asymptotes at -1/2 and 1. And let's see. Yeah.
Mr. Bachelor?
Yeah. Oh, that's a 7 in the denominator. That's, I made it look like a 2. That's a 7, huh? Is that what you're going to say? Yeah. Yeah. Thank you, I thought. And whoever else was going to say. That's a 7. I got to read my own handwriting. Did I say 7 when I wrote it down? Yeah. Have better handwriting, all of you, but you don't screw up because of your handwriting. All right, let's try that again. Now we're going to factor that denominator, which we won't be able to factor a 2 out of anymore. We'll probably take a negative out of it still. Still looks like that. There we go. That's better now. Okay. How does this factor? Anybody? How'd you factor this? 4x and an x and a 2 and a 1 probably, with a minus and a plus. So it looks like we have vertical asymptotes now. x equals negative 1/4 and 2. Now let's look. The line x equals negative 1/4 is a vertical asymptote. That's choice A. Perfect. If we were looking at horizontal asymptotes, because if we didn't have an answer choice that gave us the vertical asymptote, we'd look at horizontal asymptotes, and what would our horizontal asymptote be? It would be y equals, since the degree of the numerator is the same as the degree of the denominator, we would divide those leading coefficients. 2 divided by negative 4 will give us negative 1/2. Right? But we already found the answer. The vertical asymptote was negative 1/4. Good at home?
Yeah.
Yeah. Good here. Wonderful. All right. Let's see. And 30 and 39. Oh, I forgot about yours. What was yours, Ryan? Oh, all right. Wonderful. All right. 39. Let's see. 39 says y equals 1/2 plus 10 to the 1/x. And we want the limit as x approaches 0 of y, so of this function. This one's sort of similar to the inverse tangent one that we did. This one's got some sort of weird stuff going on here with the 2 plus 10 to the 1/x. And we'll note that since the x is up in there in an exponent, that's often, or if it's a 1/x, that's often a sign that we might want to look at what's happening from the left and from the right. So let's look at the left. Limit as x approaches 0 from the left is going to give us 1/2 plus 10 to the, approaching 0 from the left, then 1/0, right, becomes a very, very large number, right? 1 over a very small number is a very large number. And since we're approaching 0 from the left, that's a very large negative. So that becomes 1/2 plus 10 to the negative infinity. And 10 to the negative infinity should be 1/2 plus 10, right? Plus 1/10 to the positive infinity, right? That's how we deal with the negative exponent. And if I have 1/10 to the infinity, that's 1 over a huge number, which is, 1 over a very huge number is 0, right? 1 divided by something very large is 0. This becomes 1/2 plus 0, or 1/2, if we look at it from the left. But if we look at it from the right, then that becomes 1 over a positive. It should be 1 over a very small positive number, because we're approaching 0 from the right. And 1 over a very small positive becomes a very large positive. And now 10 to the infinity is very large, infinite. 2 plus something that's infinite is still infinite. And 1 divided by something that's infinite is 0. So from the left-hand side, it's got a horizontal asymptote of 1/2. But from the right-hand side, it has it of 0. And what did the question ask? Did they find the horizontal asymptotes, or it says find the limit, right? So the limit is x approaches 0 of y doesn't exist because the limit from the right and the left are not the same. Good? Yeah. Everybody here good? Good at home, whoever asked that one? Justin, you good with that? Wonderful. Any other questions from the limits multiple choice? Okay. Questions from the derivatives multiple choice? 30? All right. You guys all have done both of these multiple choice packets, right? Yeah? What? Most of them. Oh. So number 30, we're not going to do. Because if you look at number 30, it says BC only on it. Yeah. You don't need to do that. There's all, yeah. Check for the marks on the side. Other questions from the derivatives multiple choice? People at home, questions from the derivatives multiple choice?
I'm having trouble on the simplification of number 11.
Simplification of number 11.
Like, I know how to do it, I just don't know how it simplifies down to just secant.
I got it. All right. So we're looking for the derivative of this. We're looking for the derivative of this. So the derivative of natural log of u is 1 over u. And then times the derivative of u, right? So times the derivative of secant x plus tangent x, which is secant x tangent x plus secant squared. So you're good with that, you said, right? And then, let's see. Yeah, I don't know. It simplifies the secant? Yeah, it definitely simplifies the secant. The way we're going to do that is we're just going to factor out a secant x from the numerator. So if we do that, we're going to get secant x times, not secant x, I just factored that out. Secant x times tangent x plus secant x, and then over secant x plus tangent x. And secant x plus tangent x and tangent x plus secant x are the same thing. So cancel that out. And we just get secant. Does that make sense?
Yeah, I'm just dumb.
Oh, bummer. That's gonna make the AP test hard. For the next 8.5 weeks of this class. No, you're not dumb. That's what teachers are supposed to say. Yeah.
Thanks.
Yeah, so for 14, what is the original problem? Is sine of 1 over x? Yeah. And so there is a rule for the derivative of 1 over a function. You can use the reciprocal rule for it. But you don't need to do that. If we want to take the derivative of this, it's just cosine of 1 over x times the derivative of 1 over x. Okay? And the derivative of 1 over x, that's just x to the negative 1. Right? Just taking the derivative of x to the negative 1, so that's just negative 1 x to the negative 2, or negative 1 over x squared. You just use the power rule for it. So you got negative cosine 1 over x over x squared. That's my guess. That's how they wrote that. But no, they wrote the fraction out in front. Does that make sense? Yeah, the reciprocal rule, if you remember, the reciprocal rule says the derivative of 1 over some function is equal to the opposite of the derivative of that function that's in the denominator over that original function. That's the reciprocal rule. And it's just, I mean, all it is it's the quotient rule, except that the numerator is a 1, and so part of that term in the numerator cancels out when you do the quotient rule. This shorthand to get that easier. Okay. 42. Sure. As long as it's not another BC only one. All right, yeah. All right, 42. Okay. We got 2x cubed minus 6x. And we are looking on the interval 0 to √3. We want to know if the tangent is parallel to the secant anywhere on that interval. So We gotta then remember what a tangent line is and what a secant line is. Probably know what a tangent line is, right? Remember what a secant line is? That's probably the problem you're having. You don't remember what a secant line is? Yeah. Anybody remember what a secant line is? Or people in Zoom, you remember what a secant line is? Okay, secant line. A secant line is it's just a line through 2 points of a function. That's all it is. So we talk about the secant line of this function. We're just talking about the secant line, the line that goes through the point 0, through the point at 0 and the point at root 3. So the point at 0 is 0, 0, and the point at root 3, is that 2x cubed minus 6x or 2x squared? 2x cubed, okay. So the point at root 3 would be then root 3, let's see, root 3 cubed should be 3 root 3, times 2 is 6 root 3, minus 6 root 3, so root 3, 0. So we'd see that the slope of the secant line is what? To be y2 minus y1 over x2 minus x1. 0, right? So the slope of the secant line is 0. So the question is really asking us, is there anywhere on this interval where the tangent line has a slope of 0? So we'll figure out what the tangent line slope is by taking the derivative. That should be 6x squared minus 6. And if we factor out the 6 and get 6 times x squared minus 1, we'd see that x is positive or negative 1. And so it looks like there's 2 places where it has a slope of 0. One of them, negative 1, is not on that interval, but positive 1 is on that interval. So it's like, that makes sense? You sure? Okay. All right. You sure? Okay. Do you want me to further explain? I don't know if there is further explaining, but you're good? You sure? Okay. All right. People at home, are you good with that?
How do we know that that slope is 0
Which slope?
for the tangent line?
Oh, well, we set the derivative. I didn't write equal to 0. We set the derivative equal to 0. I should have wrote equal to 0. Yeah. But yeah. Anytime that we're looking for, I mean, that's the slope is the derivative. So set the slope or the derivative equal to 0 and solve for the x values. Does that make sense?
Yes, thank you.
Sure. Yeah. Does that help, Sarah? That's even better now? Oh, good. Wonderful. Other questions from the derivatives multiple choice? I have this either really, I don't know, I have this really bad feeling. Maybe it should be a really good feeling that none of you have questions because you just did a great job with all of these and had no problems. But I have this really bad feeling that the reason there's no questions is because you guys actually haven't done the problems. Should I have that bad feeling? Because when I did these in quarter 3, we spent like an entire day going through just the derivatives multiple choice section. So should I feel really good that everybody has no questions and you did them all and you're feeling brilliant, or should I feel really bad that you just haven't done them? You have another question? Okay. No answer to my question, but we have a question for me. Okay. 55. See, it seems like I feel like you're the only one that's done them. Concerning. No? That's a BC only. Oh, no, 55 is BC only also. Yeah. So is 56, and 53, and 54. They're all fun. They're all easy. Okay. 59, yeah. Okay. We've got 59. There's some chart here that we're going to have to reference, but I'm going to write out what the problem says. We've got d equals 1 over G prime, and it wants us to find D prime of 1. Right? Yep. Okay. I'm going to keep the book here because I'm going to need the chart to look at it. So first up, we want to find the derivative of D. So the derivative of D should be, we could use the reciprocal rule that we were just talking about, right? This is 1 over a function. So it should be the opposite of the derivative of that function, which would be G double prime, divided by G prime squared. Okay? And so then we'll just have to look at our chart and evaluate all those things then. 1. Oh, they didn't give us, they don't give us G double prime, do they? No, that's a problem. Let's see, what's G prime of 1? G prime of 1 is -3, so that should be 9. Let's see, did they say, let's see, did they say that the answer was C? Is that what they said? I could look. Or like 59. Yeah, okay, so I think they, okay, that does say D prime of 1. Oh. We're going to restart this problem, and we're going to work on our literacy skills because it's not. That's a comma. That's 1 over G. If D equals 1 over G, comma, then D prime of 1 equals. So we're not looking for 1 over G prime. Everybody that's looking at the multiple choice, see that I thought that was a prime, but that's a comma. Was that the problem you had with it too? Yeah. Yeah, it really does look like a prime, not a comma, but all the other ones have a comma after. They're like, if A equals F plus 2G, comma, then. So I think that's supposed to be a comma, not a prime. So now it should be negative G prime over G squared. And so then we'll go in and look at what is G prime of 1 on the chart. G prime of 1 is -3. So we'll have -3. And then G of 1 is 3. And so that will give us a 3 over a 9 or 1/3. Those of you at home, you see, it looks like a prime, but it's a comma. You couldn't tell, that's fine. Why would it be G prime squared? The quotient rule says V derivative U minus U derivative V over V squared. Okay. Denominator is always the original function, denominator squared. So same thing here, right? That's, if you do it with a 1, it's V, so G times the derivative of 1 is 0. That's why the first term goes away, then it's minus derivative of the denominator times the numerator, which is just going to be negative G prime in the squared. Yeah, no, it's not a typo. We just misread it. That's a comma. It's just 1 over G. Yeah, it's just 1 over G. So if D equals 1 over G, comma, then D prime is 1. But we were reading it if D equals 1 over G prime. You can tell too, like if you look in the chart, the primes are like straighter than that comma is. You know, you can see they're different, but it sure is misleading. Misleading enough that it misled me. 62, yeah, I can do 62. Make sure I find my commas in this one. You guys at home, you can type questions in the chat if you have them too, you know. All right, 62. Says we have the function n, which is f of g of x, and we want to find m prime of 1. And so back when we were reviewing our derivatives and stuff, I was like, chain rule, right? When you take the derivative of the composition of a function, we want to remember the formula for the derivative of f of g of x is f prime of g of x times g prime of x. So that should be m prime. And we want m prime of 1. So m prime of 1 should be f prime of g of 1 times g prime of 1. And according to the chart, we've got g of 1 is 3. And g prime of 1 is -3. And so then we have to find now f prime of 3, because that's what we end up with once we evaluate g of 1. And what is it? F prime of 3. F prime of 3 is 4. So this becomes 4 times -3. And they like to put questions like this on the AP test in the multiple choice. So they give you a chart, and then they'll give you some like quotient or composition or reciprocal like the last one we did, or like a multiplication of the functions or something, and then ask you to evaluate the derivative of it. But really they're trying to evaluate, do you know what the rule is? Okay, yeah, I know what the rule is for the chain rule, so now I just plug in the numbers from your chart. I almost can guarantee that on the multiple choice you'll see one. Almost guaranteed. People at home, are you okay with that?
Yeah.
Wonderful. Great. Other questions? Yeah, Sarah. Huh? Sure. 65, they give us a graph. The graph looks something like this. I guess there's no arrow on that, but that's. And it marks the point here as A. And it just says that this whole thing is G prime. And then they ask us which of the things about G are true. So they've given us a graph of G prime, and then they're asking us about G. And so first off, is G continuous at x equals A? Well, does the derivative exist at A? There's a point there, right? I sort of half filled it in, but that's filled in. The derivative exists at A. If the derivative exists at a point, then that means the function must be continuous at that point. So a function cannot have a derivative and be discontinuous at a point. So number 1, which says G continuous at A, yes, that's true. Then it says G is differentiable at A. Well, this is the derivative, right? So the derivative must have existed at A. Right? Just because we have a corner on the derivative doesn't mean that G didn't have a derivative at A. Okay? So here that G is differentiable at A, yep, that's good too. And then the third part is G is increasing in an interval containing A, and that would also be true. Interval A. That's also true because a function is always increasing when its derivative is positive, and it's positive before A and after A. So, yep. So it should be all three. It should be choice B for that one.
So if it wasn't.
Right. Then you would say then 1 would be true, and 2 would not be true, and then 3. I mean, I guess they probably wouldn't ask about 3, but 3 would be true because it would be increasing on that point at A. They wouldn't ask that. Yep. Or if they were asking, like, if they said, if number 2 said G prime is differentiable at A, that would not be true because G prime doesn't have a derivative at A because it's on the form. Does that make sense? Cool. Other questions? People at home, are you good with that? Are you guys there? Have you done the multiple choice? Do you care? Oh, somebody said something in the chat.
Yeah.
Ooh, somebody asked a question in the chat from the Zoom. That's exciting. 67. 67. But I know you guys are still there, at least a few of you. All right, 67. They give us another graph. This one looks like this. I went way too far on that. Let's see, that's 7, and that's 4. And let's see, the function whose graph is shown has f prime equaling to 0. So this is f. So this is f, and we want to know when does f prime equal 0. So when does the derivative equal 0? The derivative can equal 0 at a maximum or a minimum. But it can also have a max or min when f prime is undefined. And if we have a smooth curve for our max or a min, right there, at what does that look like at 2? At 2. Then that's when the derivative is 0. But the derivative would be undefined if we have a corner or cusp and looks like that's happening at x equals 5. So the answer to 67 should just be at 2 ohm. Does that make sense? Whoever asked that one from the Zoom? Now I forgot who it was. You guys good? Yeah? Okay. Cool. Everyone here good with that? Great. Other questions from the derivatives multiple choice? Austin, you got any questions on them? You did them all? Oh, wonderful. 68, yeah. Hopefully, I can turn the page. All right. 68. 68 says they give us a function here, and then they want us to estimate the derivative of it, right? So they give us this nice little chart here, where they give us x, they give us f of x, and we have 1, 1.3, 1.4, and 1.6. And then what is it? 8, 10, 14, and 22. They want us to estimate f prime of 1.5. This is a common thing that they'll ask in the free response question. They give you like a chart of values. It'll be like, it'll be like the first part of one of the free response questions often. They'll give you a chart and then ask you to approximate the derivative of something that's not in the chart. So all they want you to do is recognize that the best estimate for a derivative, for the slope of the tangent line, is the slope through 2 points surrounding 1.5. So they say, find the slope between 1.6 and 1.4. That's going to be your best estimate for the slope at 1.5. So we'll just do 22 minus 14 over 1.6 minus 1.4, which is 8 over 0.2. Like that's what, 40? Yeah. That makes sense? People at home good with that? That's important because when we start doing the free response, that's going to be like 1 or 2 points on a lot of the questions that we do. So that's a good one to know how to do. And it's easy. You just gotta know what they want from it. You guys good at home? You good?
Good.
Okay. People here good so far? Other questions? Zoom people, other questions? There, other questions? Okay. I figure you're the one asking questions here. So I'm going to ask you. Zoom people, any questions? I don't believe you when you all say that you've done all of them. Some of you probably aren't telling the truth. 77, yeah. Hey, we'll put 77. Are we in the calculator section of this one yet or no? Yeah, we are. Just making sure. Some of these it says you can use a calculator for. Just in case we need it. All right, 77, right? That's what you said, 77? All right, they give us another chart. For people that don't have the book in front of them or their paper in front of them. Good. We'll write out the chart. There's X, whatever. 2, 4, 6, 8, 10. And 30, 25, 20, 25, 30. Yeah. And then they ask which of the following things must be true. And it also tells us, and this is going to be, they wouldn't tell you if it wasn't important. It says that f is continuous and differentiable on the closed interval to 10. They wouldn't tell you that if that wasn't important. So the first thing, it says f of x is greater than 0 for 2 to 10. Well, it sure looks like f is greater than 0 for 2 to 10, doesn't it? Yeah. But I don't know if the value is at 3. Maybe at 3 it was negative 100. Right? That's possible, isn't it? Could be. People at home, right? Couldn't it be? Negative 100 at 3? Doesn't look like it's going to be, but it could be. So we can immediately eliminate choice A. Nothing in the chart, nothing that's given to us guarantees that f is always above 0. It sure looks like it, but it's not guaranteed, and it's, which must be true. So we'll write A. No, not A. B. B says f prime of 6 equals 0. So now they want us to be like, well, I can't find f prime of 6, but my best approximation for f prime of 6 between, at 6 is the slope between 4 and 8, which is 0. But we have to remember that's just an approximation. We're not guaranteed that that slope is 0. We know that based on the mean value theorem for derivatives, if we look for the slope between 4 and 8, 25 minus 25, 8 minus 4, that's 0. The average rate of change is 0, which means somewhere between 4 and 8. The instantaneous rate of change is 0. That's the mean value theorem. But it doesn't guarantee that it's at 6. Right? It's just got to be somewhere between 4 and 8. So not guaranteed. C says f prime of 8 is greater than 0. Well, I mean, it seems like f prime at 8 is greater than 0 because we've gone from 20 to 25 and then from 25 to 30, right? Seems like the derivative is positive, right? It seems like we're increasing. But like we said before, maybe the value at 7 is actually 100. Say the value at 7.999 is actually 100. And then at 8, it's 25, right? Then we'd be decreasing, wouldn't we, most likely? So that's not guaranteed either. It sure looks like that's true, but it's not guaranteed by what's given to us. Okay? Does that make sense, everybody? Same with D. The maximum value of f on 2 to 10 is 30. I mean, with all the values they gave us, sure, yeah, it's 30. But 7.999 could have been 100 for all we know, right? So it's not guaranteed either. So it looks like, without even looking at it, it must be E. Let's see what E is. Yeah, for some value of x on the interval 2 to 10, f prime is 0. And we've already shown that somewhere between 4 and 8 it must be, but also somewhere between 2 and 10, 30 minus 30, or 10 minus 2 is 0. The average rate of change between 2 and 10 was 0, so the instantaneous rate of change, the slope must be 0 on that interval. So it's got to be choice C. Does that make sense? There, you good with that? Yeah. Ryan, question? Say that again? Right, well, and also, like, I mean, yeah, they give us these values, right? But that doesn't mean that there aren't some other values that are certainly higher. People at home good with that one? That's a good one. They like to give charts and ask you to interpret the charts, which is why we're doing the multiple choice, so we can practice those. Yeah. Ooh, my internet connection is unstable. Exciting. I got a chat. Ooh, wow, my internet connection was unstable. Fancy. Why it is not B. Yeah, I can explain why it's not B again. Let's see, what was B? B says f prime of 6 equals 0. Okay, so we aren't guaranteed that the derivative at 6 is 0. We know that somewhere between 4 and 8 is 0 because the average rate of change between 4 and 8 is 0. So we're going to write the average rate of change on 4 to 8 is 0, which means that by the mean value theorem, because the function is continuous and differentiable, the instantaneous rate of change equals 0 on 4 to 8 somewhere. But it doesn't guarantee where that instantaneous rate of change of 0 occurs. We just know it's somewhere between 4 and 8, but it doesn't have to be at the midpoint of it. It looks like it could be, right? But it doesn't mean that it is. Just because this is the lowest value that we see doesn't mean that that's where it is 0, right? This could still be going, our function could look like, we could draw a function that contains these points. Here's 30, here's 25, here's 20. And we could be going, 2, 4, there's 2, there's 4. Then we had to hit like 6 at 20, 6. And then we went like way down here, but then by the time we hit 8, we came back up to 25. Right? So that minimum didn't actually occur at 6. It occurred somewhere between 6 and 8. Does that make sense, Tim?
Yeah, thank you.
Yeah, no problem. Everybody good at that one now? It's all about what does the chart guarantee, what must be true. And a lot of the things they stated look like they're true, but they're not certainly true. Other questions from the multiple choice? Anybody at home? Before Sarah asks her next question. It's good. I appreciate that you're asking that. This was the point of today. Oh, it's good. I spent the entire period in quarter 3 going through these. So 76. We're going backwards now? Okay. I see. All right, 76. 76. The left half of the parabola is a one-to-one function. Okay. Cool. The inverse is also a function, so let's see the left half of x squared minus 8x plus 10. What is that? Somewhere over here, 4, right? It's going like this. Okay, that's the left half of this parabola. It's probably not, so that's not. I should have drawn it with that. It doesn't even really matter what it looks like, but we'll draw it anyway. Here's 4, and somewhere down here. There's the left half. Okay. We want to find g prime of 3. Okay. So we are looking at the inverse rule for this because we're talking about the inverse of f. And so we remember if we're looking for f prime of a, that's 1 over g prime of b, if f and g are inverses. So this was our inverse rule, right? And f contains the point a, b, G contains the point B, A. This is our inverse rule. F contains the point AB, G contains the point BA. F and G are inverses. The derivative of F at A is equal to 1 over the derivative of G at B. So really all we're looking for here is we want G prime of 3. So we're looking for G prime of 3. That means that G contains some point 3 something, right? Must have an x value of 3 because otherwise we wouldn't be able to find the derivative of 3, which tells us that F must contain some point something comma 3. Okay? And so G prime of 3 ought to equal 1 over F prime of whatever this value there is, right? Whatever that x value for F is. So all we need to do is figure out what x value on F gives us a y value of 3. Does that make sense? Yeah, okay. So we'll do that. I didn't write down, I put down the book, I didn't write the function. What was the function? X squared minus 8x plus 10. So we just want to know when does that equal 3. And so we'll set it equal to 0. Factor. And we'll see that that happens at x equals 7 and x equals 1. And since we're talking about the left half of the parabola, well, the left half of it would be the half with x equals 1, not the half with x equals 7. So this is the point 1, which means we're looking for 1 over f prime of 1. Everybody at home good with that so far?
Yeah.
Everybody here good with that? Riley, you okay with that? You have like a quizzical expression on your face. You were making this from your eyes.
Why did you choose 1 instead of 7?
I chose 1 instead of 7 because the problem specifically says the left-hand part of the problem. So 1 is to the left of 7. That makes sense?
Yeah.
Wonderful. Okay. So now we need to find f prime of 1. So first we'll find f prime of x. F prime of x is just the derivative of f of x, which is 2x minus 8. And we'll evaluate that at 1, negative 6. So our answer should be 1 over negative 1/6, which was choice C, according to what I looked at. Good or not? Good? Everybody else good? The inverse rule is a good rule to know. There is almost always one multiple choice question where you have to use the inverse rule. It usually shows up in like the last 3 questions of the multiple choice. Well, I'm not guaranteeing that, but like I would say 75% of the time it's in the last 3 questions. Will it be this year? I don't know. Might be. Usually it is. Good? Everybody good? Other questions? Ooh. Somebody asked a question in the chat. 87. Nice. All right. It's another inverse rule question. All right, we got f of x is equal to x cubed minus 3x squared plus 8x plus 5. And g and f are inverses. We want to know g prime of 5. All right. We want g prime of 5. So g prime of 5, that means that g has a point 5 something, which means that f has a point something 5. And all we need to do is figure out when f equals 5. Okay? So x cubed minus 3x squared plus 8x plus 5 equals 5. We cancel out those 5, or subtract the 5, and that just becomes equal 0. And so easiest way to do this would be to factor out an x. And we should really easily at first be able to see that x equals 0 is certainly a solution to that. Now, without checking, I'm going to guarantee that there's no other solutions to this, because if there's no solutions to that quadratic, because otherwise we wouldn't know which x value to put here, because they didn't give us any clarifying information. Like in the last one, they said the left part of the parabola, so we knew to use 1, not 7. Here they didn't give us any clarifying information, so there's not going to be any other solutions to this. But we can prove that because we know the quadratic formula, right? And the discriminant of the quadratic formula, the part inside of the square root, b squared minus 4 times a times c, comes out to be negative. And so if the b squared minus 4ac is negative, there are no real solutions for that quadratic. So x equals 0 is our only choice. And so g prime of 5 is 1 over x prime of 0. And just like the last one, we're going to find f prime of 0. F prime is 3x squared minus 6x plus 8. And 0, that should be 8. And so 1 over x prime of 0 be 1. Does that make sense?
Yes, thank you.
Sure. Yeah, right. Was that the last one we just did? It was negative 1/6. Everyone good with what did I just do? 80, was it 87? Other questions? Actually, let's stop with questions on this just for a second. Anybody have any questions from last night's homework? Because we're gonna have a quiz on it tomorrow. I can answer questions on it tomorrow also, but sure. What was 5? Okay, what was 5? Anybody have the question in front of them? It's amazing. My phone unlocks now with the Face ID with my mask on. Absolutely amazing. It started doing it yesterday. I know. It's like, I don't know. Google has like read my brain or something. I don't know. I got it up here. I was pulling it up on my phone. Okay. 1 minus x squared. Oh, so 1 minus x squared. So that's this. That's probably looks like this. And the x-axis. So we're talking about this region. This is the region we're talking about. 1 minus x squared in the x-axis. Cross sections perpendicular to the y-axis are squared. So perpendicular to the y-axis. Oh, that's a really bad looking square. Pretend that was a square. It looks good. Okay, those are squares, right? So good with that? Yeah. So since it's perpendicular to the y-axis, we got to do it in terms of y. So the thickness is going to be dy, which means we need to write the y values for our limits. So we're going to do an integral from the lowest y value, which is 0. And since it's 1 minus x squared, that highest y value is going to be 1. Good with that?
Yeah, I was
Right, do it in terms of y, so you got to go bottom. Okay, we'll finish that. But this distance over here is x, right? Which makes, yeah, since this parabola is symmetric, we're also going to go x units over this way. So the length of one of the sides of the square is 2x. The area of the square is x squared, or 2x squared, or x squared. And we want to do it all in terms of y, though. And since we had 1 minus x, y equals 1 minus x squared, we know that x squared should be equal to 1 minus. So we're going to take a 4 from the x squared, put it out here. 1 minus y to the side, dy, and then we. Does that make sense?
Yeah.
We'll finish off just for fun. But what's more fun to do? That's right. Y minus y squared over 2, 0, 1. 1 minus a half. Plugging in the 0 is just 0. So 1 minus half a half, half of 4 is 2. Good? Yeah. Everybody good with that? Yeah. Oh, another question.
Question number 4.
Yeah.
It's like the cross section, I think, and then you replace x with 1 minus y next to
Let's see. Okay, this is the one I gave like what were the points? 0, 0, 0, 1, and 1, 0, right? And so we drew a triangle there. So we need to find the equation of that line. And so this is a line that has a slope of -1, because we're going from 0, 1 to 1, 2, slope of -1. And it crosses through the y-axis at 1. So that equation is y equals -x plus 1. So I think that answers the question that you were asking. I can finish it if you want. Cross section is perpendicular to the y-axis, so equilateral triangles. Okay? So, different color. So, this is number 4. We know that the area is the side squared times √3/4 because we memorized that yesterday. And then the side length is just the x value that I've gone over. And so x is equal to 1 minus. So then we'll integrate 1 minus y squared. Put the √3/4 out in front, everyone. Lowest y value is 0, highest y value is 1. And then distribute that out and integrate. Does that make sense?
Yeah.
Anybody here want me to, or in Zoom, want me to do the integral itself, or are you okay with the integral? You want me to do the integral? No? Oh, you have another question? Anybody want me to do the integral to actually evaluate it? It's on the, it's on the notes, or it's on the answer key.
How do you know it runs from 0 to 1?
It goes from y equals 0 to y equals 1 just because in the problem I said that it was the triangle formed by the point 0, 0, 0, 1, and 1, 0. So the highest y value is 1. That's the point 0. Does that make sense?
Yeah, thank you.
Yep. Yep. 6? Sure. Still amazed that my Face ID works on my phone with the mouse. Yeah. Keep opening it up to look at the problem. Number 6. I did 1 minus x squared again. Did I do a lot of 1 minus x squared on this? No, just the 2. Okay. 1 minus x squared again. And now we got cross section perpendicular to the x-axis or semicircle. Well, the semicircle, right? 1 minus x squared. So if they're semicircles, that means that the area of each one should be 1/2 pi r squared. Good with that? Yeah. Then we got to find the radius. Well, we'll note that the diameter is however high up y we go. So the diameter is 1 minus x squared. So the radius ought to be half of that. 1 minus x squared over 2. And so then our integral just becomes, since we're doing this one in terms of x, because it's perpendicular to the x-axis, we're going from -1 to 1. I've got a 1/2 pi that I can pull out front. The r squared is 1 minus x squared over 2 squared dx. And then since I could distribute that squared to everything, so that becomes 1/2 pi times the integral of 1 minus 2x squared plus x to the 4th over 4 dx. And then the 1/4 that's there then can just be pulled out and make this a pi over 8 out in front. And then that integral should be pretty straightforward, I think. Is that good, or you want me to finish the integral? Sure. Okay, so we'll take the 4, we'll pull the 4 out front. Or okay, 1/4 out front. So it becomes pi over 8. And then 1 plus x. And we had the minus 2 squared, which is that we minus 2/3 x cubed, and then plus x to the 5th over 5. So we'll have x minus 2/3 x cubed plus x to the 5th over 5. Does that make sense or no? Yeah. I'm not sure. Maybe in the answer key, I might have done something where I was like, did I just do it from 0 to 1 and double it? No, I just did it from -1 to 1. Or I did do that? I did not? I did -1 to 1. It's possible if you want to, because it's symmetric, you could have done from 0 to 1 and then doubled it. But so -1 to 1. That's fine. This is 1 minus 2/3 plus 1/5. Then minus -1 plus 2/3 minus 1. Yeah. Then there's arithmetic. I don't know. What did the arithmetic come out to be? 2 pi over 15? Yeah.
Is that like on a quiz or a test where we did? Because that's what I did. Like I
Yeah, that's fine. Yeah, that's totally fine. You can do that anytime if it's symmetric across the y-axis and you're going from -2 to 2, you do 0 to 2 and double it, that's fine. Yep. Makes the arithmetic easier. Yep. Are there questions from the homework? Anybody at home? Good with that one? Questions from the homework? Got time for maybe one more? Oh. 2. All right. What was 2? Before we can get through 2 real quick here. Of course, now it is. Negative x squared over 9 plus 4. So negative x squared over 9 plus 4 is just a downward facing parabola that goes up to 4. And the cross sections are rectangles. And this is y, and it says that the heights of it are twice this length across the plane. So height is 2y. So the area of that should be 2y squared. But because the thickness of these are in terms of x, dx, we need to write this in terms of x. And so now I forgot what was it. Y equals negative x squared over 9 plus 4, I think. All right. Yeah. So we'll just replace the y with negative x squared over 9 plus 4. And we'll have 2 times negative x squared over 9 plus 4 squared dx. And we'll integrate that from where do they intersect? -6 and 6. So you can figure that out just by solving that integral or solving that equation for 0. Does that make sense, Angelina, for the setup there?
Yeah, it's just that when you wrote it on the answer key,
Huh?
you made like when you wrote it on the answer key, you made like when you expanded, like when you plugged in the numbers, you added one of them, and I don't get why you added instead of subtracted.
Let me look. Which part are you talking about? Like when
The last line where it's like plus 8 times -6 to the 3rd power. I don't get why you added there.
Times -6 to the 3rd power. Had I distributed my negative sign through? I hadn't distributed my negative sign through there, had I? Good question. Bye, people that are in person. You're welcome. See you all on Zoom tomorrow. Yeah, good question. I might have just written that wrong. Hopefully I didn't evaluate it incorrectly. I'll have to take a look. Yeah, I should not have changed that to a plus though. That should definitely have still been a minus. So I'll check and make sure I arithmeticed correctly, even though I wrote the plus instead of the minus. Yeah, I'll have to look at that. Good. I guess people that are leaving Zoom, goodbye.